Hello everyone, and today we're going to tackle about the mole concept. Here are the objectives. First is to define a mole, and next is to illustrate Avogadro's number with examples. Fun fact, did you know it is often referred to as Avogadro's number in honor of Amadeo Avogadro? Mole is derived from the Latin word moles, which means a mass. Molecule is the diminutive form of this word that means a small mass. Representative particles is equal to atoms, ions, electrons, molecules, or formula units. As for the mole concept, the mole is the amount of substance that contains as many entities as there in exactly 12 grams of carbon-12. 1 mole is equal to 6.022 times 10 raised to the power of 23 particles, which is the Avogadro's number, and particles can also be atoms or molecules. How do we get the amount of moles with a given quantity? For example, we have 3.01 times 10 raised to the power of 23 atoms of rubidium. To get the amount of moles, we divide the given quantity with the Avogadro's number, which is 6.022 times 10 raised to the power of 23 atoms of rubidium. Why is that? Because it is stated in the mole concept, which is 1 mole is equals to the Avogadro's number. So with the cancellation method, we have 0.500 mole of rubidium. Here's another example. You can pause the video for you to answer. So try to calculate 8.08 times 10 raised to the 22 atoms of krypton. Same with the previous example, we divide the given quantity with the Avogadro's number, and here we get 0.134 mole of krypton. So let's try a bit challenging problem. How do we get the number of moles if the mass is given? Here we have 64.1 grams of aluminum. To get the number of moles, we divide the given mass with its smaller mass, which is 26.96 grams of aluminum. And here we get 2.38 mole of aluminum. So here's another example. We have 28.1 grams of silicon. And try to solve it yourself. Same with the previous example. We divide the given mass with its smaller mass. And here we get 1 mole of silicon. So here's the last example. What if we're looking for a specific mole in a compound? And here we need to find how many moles of chlorine are there in a 4.5 times 10 raised to the power of 23 molecules of magnesium chloride. In order to get the number of moles of chlorine in a magnesium chloride, which is a compound, we multiply 4.5 times 10 raised to the 25 molecules of magnesium chloride with the number of atoms of chlorine, which is 2, and divide it with the Avogadro's number, which is 6.022 times 10 raised to the power of 23. And here we get 149.452 mole of chlorine. So here's an overview. The mole is a unit for counting particles in a given mass of a substance. Each mole of a substance is made up of 6.022 times 10 raised to the power of 23 particles. The molar mass of a substance is the mass in grams that is numerically equal to the atomic mass or formula mass of the substance. And that will be all. Thanks for watching, and I hope you learned a lot from our video.